Hey class, this week's lesson is on factoring polynomials. So this is basically a lot of review and a little bit new at the same time. So when you have an a value of 1, notice it's in standard form. When the a value is 1, we can go ahead and start by writing down our two parentheses, which represent our two factors. And then we can break x squared into x times x. Remember, when you multiply, you add the exponent. So x times x is x squared. Now, since the a value is 1, we can just think, what two numbers multiply to give us 12, a positive 12, and they have to add to give us a positive 7? Pretty simple, right? Positive 4 and positive 3. They multiply to give us 12, and they add, if you think of the inner plus the outer, if you're doing FOIL, you have 4x and 3x make 7x. And so when the a value is 1, then you can factor just like that. Now, if you can't think of two numbers that multiply to give you this and add to give you this, then the answer might be unfactorable or not factorable. Okay, let's look at this next example. Notice here the a value is not 1. But one thing you got to notice here is the greatest common factor. So if you look at the three numbers, you can see that 2 goes into all three of those numbers. So we would want to start off by factoring out a 2. And remember, factoring means to divide. So dividing by 2, we get 1x squared. Dividing by 2, 5x. Dividing by 2, 6. So sometimes you can do that. So keep an eye out for that when you can factor out a greatest common factor. So then we're going to drop down the 2, make our two parentheses, break up the x squared, and then the two numbers are going to be positive 3 and positive 2. The better you know your multiplication facts, the easier this will be. 3 times 2 is 6, 3x and 2x add up to 5x. Okay, let's take a look at this one. So notice the a value is not 1, and you cannot factor out a greatest common factor. So this is where we're going to go ahead and do our x factor, multiplying our a times our c, and dropping the b value down below. So now at this point, we're trying to figure out is what two numbers multiply to give us 100 and add to give us 29. Well, we should come up with 25 and 4. They multiply to give you the top number, and they add to give you the bottom number. So then we put our a value on top. We reduce if we can. Remember, if this was a negative, the negative would stay on the bottom, but it's positive, so it's positive. So this is going to factor. So this is going to give us x plus 5, 1x plus 5, and then this one cannot be reduced, so this one's going to be 5x plus 4. Now, for some reason, both of them reduced, and both of them gave you a 1 on the top, then that means our a value we would need to put on the outside. Otherwise, we would have lost it. Okay, so now here are some newer problems. Notice these are to the 8th power. Well, this is to the 8th power. This is to the 4th power. 4 is half of 8. And then we have a constant on the end. This is a quadratic pattern, which means we can factor it just like we factored these. These are all quadratic. The quadratic pattern, the first power, okay, is even. And then the second power is half of this power. So 1 is half of 2. 1 is half of 2. 1 is half of 2. So here we have 4 is half of 8. So we have a quadratic pattern. So when we break this up, the first term, remember, it's got to add to 8 because we're going to be multiplying these together. So it's going to be 4 and this is going to be 4. And it's always going to break out evenly to make 8. This won't be 6 and this won't be 2. That will not work. Okay? So the two numbers, 14 and 9, that's going to be 7 and 2. 7 and 2. They multiply to give you 14, and 7x to the 4th plus 2x to the 4th is 9x to the 4th. And so that's why these have to be the same, because when you do inner and outer, they have to be like terms. I hope that makes sense. Should. Okay, so here's an example. Right away, we're looking at the a is not 1, but notice they're all divisible by 2. So we can factor out a greatest common factor, which would be 2. They're all divisible by 2. So remember, factoring means to divide. So dividing, we get x to the 10th minus 9x to the 5th plus 18. Okay, so we have a quadratic pattern here. 10 is even, and the next power is half. Half of 10 is 5. So this is a quadratic pattern, and so we're going to go ahead and make our two parentheses, break this down to x to the 5th and x to the 5th. And then the two numbers we should use is probably going to be 6 and 3. Give us 18 when you multiply, and when you add, they give you 9. But notice it's negative. So they're going to both have to be negative. Because remember, you're adding. So negative 6x to the 5th plus negative 3x to the 5th is negative 9x to the 5th. And a negative times a negative is a positive. All right. Let's take a look at this one. Here we have an a value of 1. So it looks like 8 is our power. And then half of 8 is, not 3. This is not a quadratic pattern, okay? So we cannot not factor it. So not factorable. Because this is 8 and this is 3. For it to be factorable, it would have to be 8 and 4. Okay? Well, I hope this video helps you out as you do these problems. Have a great week, and thanks for doing all your work.